Okay, YouTube, in this video we're going to explore a little bit what we mean by coterminal angles. And so what the definition is of a coterminal angle is basically two angles that are in standard position whose terminal rays coincide are said to be coterminal. In general, basically any two angles that start in the same place and end in the same place, we say since they end in the same place, they terminate together, so they're coterminal. So one thing that we kind of want to mention here is this. If you were to have some general angle theta and it's in standard position, I want to be clear about that. Let's just kind of say that this is some angle. We're going to label this with the Greek letter theta to indicate an angle. And we say that if I wanted to find another angle that lands in the same place, it started in the same place. You know, maybe if I shift my color here like a reddish, then I'd say, well, what if this original angle here, if I would have just kind of spun around one time, what I want you to see is that it would have been the initial angle plus another 360-degree spin. That is to say, if I were to have gone around another full time from the original green angle here, then I would have landed in the same place after having started in the same place. So basically, in general, we can see that coterminal angles must differ in values by multiples of 360 degrees. So the neat thing about this is that if anybody ever gives you an angle like negative 75 degrees or positive 460 degrees, if you want to find any other angle that is coterminal to this, all we need to do is either add on or subtract off multiples of 360 degrees, usually just one or two multiples. And so let's take a look at this. It says by directions here, we'd say find one positive angle, one negative angle that are coterminal with each of the given angles. So this negative 75 here, let's go ahead and start by sketching it. We know that it's in standard position, so it leaves a positive x-axis, and because it's negative, it rotates clockwise. So we say negative 90 degrees. We would know that, you know, like a negative 75, this guy right here, negative 75. That'd be like 15 degrees shy of a negative 90. So if we wanted a positive coterminal, I don't have to sketch this to show you this, but I sketched this because I want to show you that we can just verify this visually. We could say, well, what if I took this original, 390 degree rotations, which is 270, plus this other 15 we said we were short here on this original negative 75, this would be a 285 degree angle. And so basically we would say that 285 degrees would be one of the angles that is coterminal with it. And if we wanted another angle, yet another angle, we could have taken the original negative spin and, taken off another 360 degree spin off of that. And so this initial angle here, negative 75, plus another negative 360, sorry, I didn't mean to stop up here, negative 360, we would see something like this. We say negative 75 minus 360 degrees, and I'll save you the trouble here, it's negative 435 degrees, but you can see this original green angle would have spun negative 360 there, one full spin plus a negative 75, which is just this angle right here. And so what I want to show you is that numerically we could have done the same thing just without sketching the image. And so this negative 75, the two ways we're going to do this, if we're going to find a positive and a negative coterminal angle, to get us the positive one, we'll just add on 360 degrees here. And if we add on 360 degrees right here, getting a calculator out, you'll see that you get 285 degrees. And if we were to take negative 75 degrees and subtract off 360 degrees, we get negative 435 degrees, which were certainly the two angles that we got up here visually. So let's take a look at this 460. Again, 460, that would be like what? That would be like, clockwise, 360, one full rotation, plus another like 100. So here's like 90. So it would be 10 degrees past 90. So like, right there. We'd say here's our 460 degree rotation. If we wanted a positive angle that's coterminal with this, we could just say, let's just choose this angle right here, which would be 100. But the way we're getting this is we're saying, let's take 460. And because we want one positive and one negative, let's do this. Let's subtract off 360. We'll get our 100 degrees that we've confirmed here visually. But let's subtract off, take 100. Since it's the same as 460 anyways, at least coterminal, let's take 360 off of it. And we get a negative 260 degrees. So here's our other negative coterminal angle. But basically, this negative 100, or this 100 right here in blue, right there, if you were to add 360 onto it, you get back to your 460. But if you were to take 100 off of it, 360 off of it, sorry, you get negative 260, which is this angle that you see right here, which is the same angle we just verified numerically. So in terms of finding coterminal angles, just add on or subtract off multiples of 360. So give these a shot here. Take a look at this first two with you. 80, if we were to say 80 plus a 360 degree rotation right there, what would we end up with there? Well, 80 plus this would give us a 440, and there's one coterminal angle. But we say 80 minus 360. I suppose we would have to find the difference between these two things. It looks like a 280 degree difference, and we say a negative 280 degrees. So these would be my coterminal angles. Same thing goes for the 230 here. It's just that when we find our 230, and I suppose we add on 360 degrees, that would be a positive one. when we do 230 minus 360, will this be negative? And in this case, it will be. If we had started with any other number bigger than 360, we would have had to have subtracted off 360 twice. So taking a look at these here, 230 plus 360, looks like that gives us a 590. And when we say 230 minus 360 here, that's a difference of 130 degrees, and that would be negative. So go ahead and take a look at those other two, and that's what we mean by coterminal angles. Cheers.